everybody, this is Teacher Cheska and you are watching Science with Teacher Cheska, and today we will be tackling our Module 1 for Quarter 2, the quantum mechanical model of an atom. Our objective for this module is to explain how the quantum mechanical model of the atom describes the energies and positions of electrons. Let us begin with our pretest. Here you have 10 items and you will write down your answers on your answer sheets, and you should be able to try to answer each of the questions. Okay, so let's begin. Now, here on the first part of your module, you will learn about different things. So let's begin here. It says to talk about fireworks. So have we seen fireworks during New Year's Eve or any other occasion? And have you noticed the light that they emit? Now, these fireworks are produced by the combustion of explosive materials present in fireworks. And the explosive materials are also called metal salts. Metal salts emit characteristic color of light when heated, as shown here in Table 1. Okay, so for each metal salt, they will give you a different color of the flame. And the reason for that is because of the elements present in each metal salt. Alright, so for barium, since it is present in barium nitrate, it will give you the color green, and so on and so forth. Now, each color of light has a specific wavelength. Among the visible light, red light has the longest wavelength and the longest energy. Violet light, on the other hand, has the shortest wavelength and the highest energy. So when compounds of different elements are heated over a flame, it comes to a point where the hot gaseous atom begins to emit light of a definite color. Now, analysis of this light is given off by the vapors of elements and can be done more precisely with an instrument called the spectroscope. With the use of the spectroscope, you can detect a series of narrow lines or line spectrum on the light given off by an element. So if you could see here, hydrogen, if you look at hydrogen on the spectroscope, you will find this type of light. Or the line spectrum for helium will be this, and the line spectrum for mercury will be that. Now, how did Niels Bohr explain this? He said that each line in the atomic spectra of elements suggests a definite energy transformation within the atom. There is energy transformation within each atom. Bohr stated that electrons are moving around the nucleus in a circular path or orbit at definite distances from the nucleus. So this is what he said. No? This is similar to the planets revolving around the sun. So if you notice, Bohr basically said that the nucleus is like our sun, and then the electrons are moving around the nucleus in an orbit. Now, so just like the planets, we revolve around the sun. Electrons in each orbit have definite energy. That's what he said. This energy increases as the distance of the orbit from the nucleus increases. So, the energy from electrons will increase as it gets further away from the nucleus. These orbits are also known as shells or energy levels, and they are assigned each by a number. Let's say n is equal to 1, n is equal to 2, etc. Or the letters K, L, M, N, O. As long as the electron stays in its given orbit, there is no absorption or emission of energy. If the electron receives extra energy, it will jump to a higher energy level, and this is called the excited state. The electron in an excited state can return to its original lower energy level or ground state by releasing discrete amount of energy in the form of light. So this is how it looks like, what Niels Bohr said here, no? What he said, that electrons are moving around the nucleus in a circular path at definite distances from the nucleus. So this is it. So these are the electrons, and each orbit he named either n is equal to 1 or KLM. Now this is what he said. If the electron has or receives energy, extra energy, it will jump to the next higher energy level. But when it releases an amount of energy in the form of light, it will go back to its original lower energy level or ground state. Now, this model can only describe the atomic spectrum of an atom having only one electron. For example, like that of hydrogen. Later on, Erwin Schrödinger, together with Werner Heisenberg and Louis de Broglie, made a refinement of Bohr's atomic model. They upgraded this one. Now, Schrödinger used mathematical equations to describe the possibility of finding an electron in a certain location. And this model is now known as the quantum mechanical model of the atom. So, from this type of model, Erwin Schrödinger with Heisenberg and de Broglie, they upgraded this one. Okay? Based on the quantum mechanical model, it would be impossible to plot a definite path or orbit of the moving electrons. However, we can guess the most probable location of the electron in a given instant to be within a certain volume or region of space surrounding the nucleus. Therefore, instead of the orbits or shells, no? So Schrödinger says that it is now an atomic orbital. So when he upgraded this and showed this the quantum mechanical model of the atom, so ang iyang gibuhat, ang tawag na din ani kaning region, that's region of space, is now the atomic orbital. So the region around the nucleus where the electron is most likely to be found. Meaning, dili daw gini siya ga-follow o ing ani lang na path, no? Ang electrons. It will not go like this. However, the upgraded model of Schrödinger says, posible kani siya, naani siya sa ing-ani na area. Okay? So, in this area, let me try to draw or show you a photo of that. Okay. So, this is a model that Erwin Schrödinger created. So, this is the quantum mechanical model. So, as you can see, the nucleus is here, and then the atoms are no longer like earlier wherein there is a definite path. Now for each orbital, the atomic orbital, there's a certain region. So there's a possibility that one atom will be found here or another atom will be here. So this totally changed the way we see atoms and how to find electrons in them. Now, the one that Niels Bohr have, that type of model, is still used often to signify science. Of course, he's the first one who did it. But this is how it really is being used by chemists and physicists around the world. Okay, let's continue. It also says here that atomic orbital serves as the house of the electron, and it can accommodate a maximum of 2 electrons only. Aside from the main energy levels, there are atomic orbitals and also energy sublevels late in the atomic emission spectra of elements. So let's continue. So the atomic model that was presented by Bohr is comparable to a staircase, as like this, no? You need more energy when you climbed more stairs, so it's the same thing. So you get to move to a different atomic level, you need more energy. Okay? However, what we will be answering is this. This is activity number 2, and you have to complete the table below. Okay. Don't be intimidated. This is easy. I know you can do this. So, we just have to look at the table and study this one. So, you have in your answer sheets also the same table, and the blanks are also there, no? You just have to complete it. But let's begin first with the first level. So, this is the main energy levels, or the N, and it can also be identified as the KLMNO. Oops, I will not say what's this one, kay part na siya sa inyong answeran. Okay, so let's start with K. It says here, it has one sublevel, it's S. So the number of this is 1, and then the sublevel is S. Now, what is the number of the atomic orbitals found on the level K? There's only 1. And what kind of atomic orbitals? It's only 1s. What is the maximum number of electrons that can be found in this level? There are 2. You are correct. As it says there in here, no? 2. It can accommodate only 2. So let's continue. On the main energy level L, this is number 2, or the second energy level, and you have sublevels S and P. Alright? That's a given. Next, what is the number of atomic orbitals that can be found here? Kay duha man siya, so what could it be? It would mean 2 times 2 is equal to 4. That's correct. So there you get 4. Now, it says here what kind of atomic orbital. Given man ang S ug ang P, and then upat daw ka atomic orbital, so sa first energy level, 1s ang given. So, taken na ni siya. So, 1s. That means, kay upat man ni, kani siya na ang sunod. So, pila may nabilin kung 4 minus 1 is 3p. Okay? So, you have it there. However, pila man daw ka electrons ang pwede na adini. What do we do? Since there are 4 atomic orbitals, and one orbital will only house 2 electrons, you just multiply 2 times 4 equals 8. For 4 atomic orbitals, how many maximum number of electrons can they have? 2 times 9 equals, then you write your answer. Okay? Alright, can we now see the pattern of this activity? Okay, so I will leave you to continue answering the rest of the table. Okay, so now that we're done with our activity number 2, let us continue to lesson 2, which is electron configuration. So, what is this all about? It says here that matter is composed of atoms, and atoms are made up of protons, neutrons, and electrons. And the position of electron in the atom plays a vital role in the way atoms interact with one another to form compounds. So, in lesson 1, you learned that the electron can stay at certain fixed distances away from the nucleus, and this position is called energy levels. Each energy level contains a certain number of sublevels, and each sublevel has a fixed number of atomic orbitals. The atomic orbitals, again, is the place where the electrons are most probably found. Alright, and the electrons in atomic orbital carries a definite amount of energy. Now, to track down the location of a given electron in an atom is similar to tracking where a person lives. So, you need to find out where can you find it, and as such, you will need to use energy levels, sublevels, and atomic orbitals. So, here is an example of an electron configuration. So, tracking this down, they use the notation electron configuration. So, electron configuration is the most stable arrangement in which electrons have the lowest energy. So, for example, this one is an electron configuration. Often, you just read it as 1s2, 2s2, 2p6. And this is for the neon atom. So, let's continue. In the electron configuration of 1s2, 1 refers to the main energy level occupied by the electron. S denotes the kind of orbital type is S, and the superscript 2 is the number of electrons. Now, it can also be 1s1 kasi like we said, the maximum number of electrons in an that can be found in each orbital is 2. Alright? So these are some rules that are applied in deriving the electron configuration. Let's begin with Aufbau's principle, which is also known as the building up principle. And it states that electrons occupy orbitals in order of increasing energy. It follows this mnemonic in filling up the orbital. So if you notice, you have 1s up to 8s, and then starts with 2p up to 7p, 3d to 6d, and 4f to 5f. And so the electron will fill this up first, and then it will go to the 2s, and then 2p, then 3s, 3p, 4s, 4d, 3d, 4p, 5s, so and so on and so forth. So mo daw ni siya ang pattern. So this is very, very handy when you try to answer the activities later on, okay? So keep this in mind. So for example, the electron configuration of lithium, which has 3 electrons, is 1s2, kay the maximum number of electron per orbital should be 2. And then 2s1. So 2 plus 1 is equal to 3. Tama? Alright. How about sodium, which has 11 electrons? It will become 1s2 here, 2s2, 2p6, okay, and 3s1. Alright? When you add all that up, 2 plus 2 is 4, plus 6 is 10, plus 1 is 11. Okay? Now, let's continue. Electrons occupying in Pauli's exclusion principle, electrons occupying the same orbital must have the opposite spin. So, with regards to lithium, 1s2 and 2s1, the orbital diagram would look like this, not like this, okay? For sodium, it will look this way. So the opposite spin. Hund's rule of multiplicity, on the other hand, says that when electrons enter a sublevel with more than one orbital, they will spread out of the available orbitals with the same spin before pairing. So, the orbital, let's say for P, orbital P, it has a sublevel. We have Px, Py, and Pz. That is why here 6 ni siya, no? Na siya itulo ka sublevel si 2p. So for nitrogen, this is what it will look like because it has 7 electrons. 1s2, 2s2, 2p3 gyapon siya, no? But when it comes to Pauli's exclusion principle, this is how you should write it down. Okay? You have to fill up first the sublevels. Okay. So let's try to answer what's more. So indicated here is the different electrons. You write your orbital diagram and then the electron configuration. So you can use this one for your electron configuration and the orbital diagram for this. Okay? Alright. So now we have learned that electrons have different energy levels, and as such, no? So to summarize, because of this, we have arrived with our quantum mechanical model of an atom from Bohr's atomic model that says that the electron can be found in specific circular path. This has been modified by Schrödinger, who formulated a mathematical equation that describes the behavior of the electron, and as such that the electron cannot be found in a specific circular path. However, it can be found at a particular region in space called the atomic orbital. And this model, the quantum mechanical model, describes the atom having a nucleus at the center where electrons move, and it describes the region of space where the electron is most likely to be found. Of course, electron configuration is the distribution of electrons in different atomic orbitals, and this is what chemists use since it is the most stable. So I hope you learned something today, and please answer the assessment. This is again 10 items. You can do this. I believe in you, and I hope to see you again on our next lesson. Bye!